Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to continue our discussion on measures of dispersion. And so in the previous video, we left off talking about deviation from the mean. And we went through this Excel example where we talked about the deviation as the mean minus the value. And then we said that we could take the absolute value of that to deal with the issue of negative numbers. And we took the average, and this was the average distance from the mean for any given observation. So this is going to be a very useful quick measure of dispersion. But there are a couple of others that are a little more common. And so what I want to do is I want to go back here. I want to go back up here. And we're going to start off this video talking about variance. And so variance is actually related to this idea of deviation from the mean. It just takes it a step further. So with deviation from the mean, right, we summed up the value and then we took the average. And then if we wanted to, we could make this absolute value to deal with negative numbers. But variance deals with that same issue in a slightly different way. So let's go ahead and talk about variance. So the idea with variance is that it's going to look very similar. So variance, or VAR, is going to equal, it's going to look just like this equation up here, the summation of x bar minus xi. But to deal with that issue of negative numbers, what variance does is it actually just squares the result. And then it divides it by n, and then it takes 1 away. And this statistical thing here, this has to do with the fact that we're dealing with samples. Right? In the textbook, it talked about samples versus populations. I'm not going to dig into this too much, but by and large, we're typically going to be dealing with samples. So our variance is going to be n minus 1 instead of n. So let's take a look at this equation, this variance equation, right? It's the value, it's the mean minus the value squared, summed up, and then divided by n minus 1. So let's go ahead and take a look at this equation in Excel. So we have our, I'll copy these over here. So we have our video, we have our data from before. I'm going to slide over just a little bit so it's a little more centralized in the screen. So let's go ahead and look at what this would look like. The equation was x bar minus x squared summed divided by n plus 1. So let's take a look and see what that looks like. So if we equal, this is still the average from before, so we're going to equal that minus that, right? This is the equation. This is the first part of that equation, right? This is that x bar minus xi, and we're going to drag that. So each of these is x bar minus xi. So if you've noticed, this is the exact same thing as the deviation that we did before. So this is the same thing as the deviation from before. Now what we're going to do is we're going to square it, right? That's the second piece of that example. So we're going to take that value, shift 6, which is the caret. We're going to square it. So that is going to square the value. And we drag that down. And you notice that what that's done is it's done two things. One, it's made large deviations larger, smaller deviations smaller, but it's also gotten rid of all of the negative numbers. So this deals with that issue of negatives that we dealt with over here by just making an absolute value. So then now what we do is we sum all the squares up, right? That was that next piece of the equation, right? Sum them. So we did the deviations, we squared them, we summed them, and now we take that number and we divide it by the number of observations, which in this case is 11, minus 1, which is 10. So this 10 right here is coming from the fact that we have n minus 1, right? If we go back to that document for a second, right? This n minus 1, right? That is where that 10 is coming from. So if I hit enter, our variance, so this is our variance. Our variance is going to be 0.708. And what we can do to check ourselves is if you type in VAR, you'll see there's var.s estimates the variance based on a sample. And as I mentioned before, the variance that we are talking about is the sample variance. So just to confirm, we're going to click that. I'm going to include these numbers here. And if we put the brackets around it, you'll see that we do indeed get the same answer, which means that Excel is going through this exact same process of taking the difference from the mean, squaring it, summing it, and averaging it. Okay? Oh, averaging it at n minus 1, I should say. So hopefully that made sense. That's variance. Standard deviation is going to be the same exact process. Standard deviation is going to be the same exact process. Except that standard deviation takes the variance, so it's that sum of x bar minus xi quantity squared over n minus 1. Right, that's the exact same thing as variance. It just simply square roots it. It square roots the whole thing. And this is STD. Or sometimes you'll see it as a lowercase sigma. So this is standard deviation. Same thing as variance, except at the end you take the square root. So let's go ahead and go back into Excel and let's look at what that looks like. So we have our variance here. So we've done the exact same thing, right? We've taken the deviation, we've squared it, we've summed it, and we've divided it by n minus 1. So standard deviation, I'm going to make that a little bit wider so we don't have any issues there. Right, as I said, it's you calculate the variance, so you take the variance, which is what we calculated in the last step, and you take the square root, which is SQRT in Excel. So if you do that, we get 0.8417. So this is the square root of that. And just to prove that that works, we can do the STD, and you'll see it says STDEV, standard deviation, estimates the standard deviation based on the sample. So if we double click that, and we highlight our height variable, and we hit enter, you'll see that we do indeed get the exact same thing. So again, standard deviation is just variance, but at the end you square root the value. So again, to recap what we did, we took the deviation, which is each observation, the mean minus each observation. That's how we get deviation, right? The mean or the average minus the value gives us the deviation. For variance and standard deviation, we square that value. So that's what this is. That's just the deviation squared. We then sum them up. I should put sum there. We sum them up, right? That's the next step, is to sum all of this up. And then we divide by n minus 1 because we're dealing with a sample. And that gives us variance. And then for standard deviation, we take the square root of that. So to recap everything we've talked about so far, we have the deviation, which is just the value minus the mean. If we take the absolute value and average it, this gives us the average deviation. So this is how far an average point will be. We can square the deviation instead, take the average minus 1 to give us the variance, which again is a measure of dispersion. So it's a measure of how far away values are from the mean. If we take the square root of that, we get the standard deviation. So hopefully this makes sense. And if you have any questions, as always, please reach out. Thank you.